So here's the stats part. What is the probability that a randomly selected variable would fall within 3 standard deviations of the mean? Now that's going to be all about our bell curve. If you remember the bell curve, I think there's one on your pink sheet. But your bell curve goes something like this. Yeah? You have the mean in the middle. And you have 3 bars on each side. And let's talk about these bars. The middle 2 are 34%, right?
Yep.
What's the next one? 13.5. Next one is 2.35. I'll run out of room there. 2.35. And that last one, 0.15. So, what is the probability that the selected variable would fall within 3 standard deviations of the mean? Well, this would be within 1 standard deviation. That would be within 2. That would be within 3. So if I don't remember what that is off the top of my head, all I have to do is add everything from here to here. 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35. What does that give you? 99.7%. Okay. All right. For the data set, we have, it looks like 5 questions here about the same data set. So, my first question is, are these numbers written from least to greatest? No. Let's write it from least to greatest. 1.1 I think is the smallest number. What's the next smallest number? 2.7. And then 3.1. And then 3.4. 5.2, and 7.1. So that's in order from least to greatest. Why did I do that? Because that's going to find me the median. Do any of these questions ask about the median? The 5-number summary does. Remember, the 5-number summary is your minimum, your quartile 1, your median, also known as your quartile 2, your quartile 3, and your max. Now looking at this one, my minimum is 1.1, my max is 7.1. Only option A has that, so that should be pretty easy. Find the range. How do I find the range? 7.1 minus 1.1. What does that equal? 6. Find the interquartile range, also known as the IQR. Now, I actually need to go out and fill out some more about this 5-number summary in order to find the IQR. So if the minimum is 1.1, the maximum is 7.1, what's the median? Oh, I got 2 numbers in the middle. So what do I do to find the median? Add them together and divide by 2. 3.1 plus 3.4 divided by 2 is 3.25. Then, to find quartile 1, I look at these 3, and what's the middle number? 2.7. For quartile 3, I look at these ones, and what's in the middle? 5.2. Now I know everything to find the IQR. How do I find the IQR? Q3 minus Q1. Might be nice on your pink sheet. Q3, 5.2, minus Q1 is 2.7, and that gives me 2.5 as my IQR. Find the mean. How do I find the mean? Add them all up and divide by however many there are. So 1.1 plus 2.7 plus 3.1 plus 3.4 plus 5.2 plus 7.1, and I'm going to divide by what? 6. 3.77. Option D would be my mean. Standard deviation. It says find the standard deviation of the population. Population is a little bit easier. But how do I find the standard deviation of the population? Well, the first thing I have to do is I have to take each one of these numbers and subtract the mean. Remember that? And then I'm going to square it. So I have to do that for 1.1, for 2.7, for 3.1, for 3.4, for 5.2, and for 7.1. So I got to plug all those into my calculator. Let's see. 1.1 minus 3.77. Let's put some parentheses around that. And square it. 7.1289. I'm just going to go ahead and leave all the digits for right now. Now I'm going to go back and I'm going to change the 1.7 or 1.1 to a 2.7. And I get 1.1449. Change the 2.7 to a 3.1. Oops. I get 0.4489. Change the 3.1 to a 3.4. 0.1369. Change 3.4 to 5.2. 2.0449, and change 5.2 to 7.1, and I get 11.0889. What do I do with all those numbers then? I add them up. So 11.0889 plus 2.0449 plus 0.1369 plus 0.4489 plus 1.1449 plus 7.1289 gives me 21.9934. How do I find my standard deviation from there? Because that was the hard part. I take this 21.9934, divide it by how many there were, 1, 2, 3, 4, 5, 6, and take the square root of it. So there's my number, divided by 6, and I'm going to square root the previous answer. I get 1.91, which is option what? C. So all of those go quick except standard deviation. You may want to put something on your pink sheet about reminding you of this process for standard deviation. Now this was for population. If this was a sample, we do this. That's the only thing that changes, right? So population is the whole thing. Sample, you subtract 1. Okay? All right, classify each of the following as categorical or numerical. No explanation needed, but make sure you understand the difference. What is numerical? Numbers, but specifically it's numbers where the average is going to have a meaning, or the mean has a meaning. If you average the numbers that are on basketball jerseys, that mean has no meaning, right? So that would actually be considered categorical. Categorical is usually a word type answer. So if you wanted to find height, would you say that is numerical or categorical? Numerical. Years it takes to complete college, is that numerical or categorical? Numerical. Your favorite number?
Categorical.
That would be categorical, because if you said the average favorite number is 3.4, that really has no meaning to anyone. Eye color?
Categorical.
Also categorical. How about the numbers assigned to interstate highways, like the 210, the 15? Categorical, because the average of those numbers has no meaning for us. Shoe brand? Categorical, the answer would be a word. Shoe size? I would say numerical. The average shoe size does have a meaning to it. Okay. All right, a survey asked a random sample of 50 EHS students if they planned to study more than 5 hours for their final exams. Describe the population. What's the population? All EHS students. What is the statistic? I'm actually going to skip over that one because I like to do the sample right after the population. So if the population is all EHS students, what's the sample? The 50 students that were asked, correct? Now, how do we separate statistic and parameter? Well, the statistic is whatever piece of data was about the sample. S goes with S. The parameter is whatever piece of data was about the population. P goes with P. So what did we, if I look at these, looking at statistic, we'll do that one. Is the statistic the 50 EHS students that were asked? No, that's the sample. Is it the percent of all EHS students who plan to study more than 5 hours? No, because it says all EHS students, that's talking about the whole population, not the sample. Is it the percent of the 50 sample students who plan to study more than 5 hours? Yes. The parameter would be what? Not the percent of the 50 sample students. It would be the percent of all EHS students. Okay? So these are the questions that were not on Go Formative. So they are multi-step free response, not multiple choice. They will be multiple choice on your test, but for the review they're not. So tell which sampling method is used for each scenario. Let's remind ourselves of these real quick. Systematic means that there's some kind of a system to picking them, like every third person or every fifth person. Stratified, that's where you divide your groups, divide your sample into groups, and of those groups you pick a random few people from each group, as opposed to cluster, where you have it broken down into groups and you pick a few of the whole groups. Convenience is picking the people closest to you. Simple random is exactly that. It's completely random. Self-selected means that people have to volunteer to be a part of it. So, the residents in a retirement community are split into groups based on their age. As soon as it says something about being split into groups, we know we're looking at either stratified or cluster. The difference is going to be, do they take certain groups or do they take a few people from each group? Based on their age, and then 10 people from each group are asked which classes or activities they prefer to have offered in the community center. We have stratified.
You said the difference is what?
In stratified, they split it into groups and they pick a certain number of people from each group. Cluster would be they split it into groups and they take whole groups. The easiest way I can think about this is if you have freshmen, sophomores, juniors, seniors. That's a natural splitting up of into 4 groups. If they then took all of the sophomores and all of the freshmen, that would be a cluster sampling. If they took 50 freshmen, 50 sophomores, 50 juniors, and 50 seniors, that would be stratified. Okay? All right, residents of the retirement community are randomly chosen from a list of all residents, and then their ages are recorded to find a mean age of all community residents. Does everybody in the retirement community have an equally likely chance of being selected? That makes it simple random. Okay. Residents of a retirement community are divided based on which apartment building they live in, and then 5 of the 20 buildings are randomly chosen to participate in a survey. What do we have there? Cluster. They're divided into groups, and then 5 of the 20 groups are chosen. All right. A pollster stands outside the community center at the retirement community and asks every resident who enters about their favorite activities. What have we got there? Not every resident is equally likely to enter or to participate. Only the ones that happen to walk past this person. All right. Make a line or a dot plot of the following data and decide if it is symmetric, skewed left, or skewed right. Got a lot of numbers here. What seems to be the smallest number? 2. And the largest number? 9. Okay, so here's my line right there. I'm going to say 2, 3, 4, 5, 6, 7, 8, and 9. And what I'm going to do is I'm just going to go through the list and put an X on top of whatever numbers I see. So I see a 2, an 8, a 4, a 6, 2 more 4s, 1, 2, 2 3s, a 9, a 6, a 4, a 5, a 3, a 2, a 5, a 6, a 4, a 4, a 4, a 5, a 5, a 6, 2 3s, 2 4s, and a 5. So that represents my whole list of numbers. Now, if I look at this, do you see how there's the big bump over here? And then it has a little tail over here. If the tail is over here, what does that mean? It is skewed. But what direction is it skewed? It is skewed to the right. If the tail was on the left and the bump was on the right, that's when it's skewed to the left. It's whatever side the tail is on. Symmetric would mean that your bump is in the middle. Okay, kind of like your normal bell curve. So this question is all with regards to this chart right here. Now, I'm going to clarify some of these numbers. That looks to me like it says 59.5. I'm going to say 61.5, 63.5, 65.5, 67.5. Looks like they're counting by twos. Okay? All right. Tell whether each statement is true or false based on the given histogram. So, right here, I like to start off by labeling these things. This right here is too high, therefore it happens twice. This right here is 4 high. This one is 1 high. How high is this one? 9. 1, 1, 2, 2. All right, less than 8 people are shorter than 67 inches. Well, here's 67.5. So if I add up everybody to the left, 1 plus 4 is 5, plus 2 is 7. I could say that that is true. Because because 7 people are shorter than 67.5, I can say that less than 8 people are shorter than 67. All right, there are an equal number of people who are 74 inches tall. 73.5, 74 would be right around here. And 76 inches tall. I would say false. Why would I say false? Because 74 is not an exact marking. All I know is that our 2 people are somewhere between 73.5 and 75.5. I don't know that they're exactly 74 inches. Do you get that? And I know that there are 2 people that are between 75.5 and 77.5, but I don't know if they're 76 inches. So I don't have enough information to be able to make that conclusion. There are more people between 67.5 and 69.5 than any other height. Would you say so? There are more people in this area than in any other area. True. There were 22 people in this sample. How would I find out how many people are in this sample? Add them all up. 2 plus 4 is 6, plus 1 is 7, plus 9 is 16, 17, 18, 20, 22. True. The tallest people in the group were between 67.5 and 69.5 inches. True or false? False. How tall were the tallest people in the group? Between, I think it's 75.5 and 77.5. The shortest person in the sample was 59.5 inches tall. The shortest person in the sample was somewhere between 59.5 inches and 61.5 inches, but we don't know where in that range they are.
So for those it says, was at least 59.5, you could put true?
What I could put there would be something like the shortest person in the sample was between 59.5 and 61.5 inches. That's all I know.
But I'm saying, like, if they give us a question where it says the shortest person in the sample was at least 59.5.
Yes, that would be true. If the shortest person was at least 59.5 inches, yes, that's true. All right, the tallest person in this sample was more than 75 inches tall. Well, this is 75.5, correct? Yes? So doesn't everybody in that category meet the requirement of being more than 75 inches? If they're somewhere between 75 and a half and 77? So we can say that true, the tallest person is more than 75 inches. Okay?